here's the finished product. In a little bit, we'll show you how to put it together. This turntable can be used for taking pictures of an object for a 3D scanner, or if you just want to take a cool video of a part rotating around and a nice cinematic view of something, that'd be great. Now, as far as why I decided to design this, I found a number of turntables on Thingiverse. However, some were already set up for a specific camera or a cell phone or some particular camera, and I wanted the option to use whatever camera I wanted. For instance, on this one, I'm just going to set up a tripod to take a picture of an angle, take a bunch of pictures of that angle, then raise the angle up, take a bunch more pictures of that angle, of a different angle. So I decided to make one of my own. Also, a lot of the ones I found on Thingiverse were so stiff when I printed them out that it took forever to put them together without breaking something. I broke a number of parts as I put it together, or getting the turntable to turn was a lot of work and it took a lot of breaking in, or it took supports on the gears were full of supports and that was hard to clean out, so it was just a lot of work. So I decided to design my own. Also, this is a bigger one. This is a 10-inch this is a 10-inch table. This is a 10-inch table, not just a little 6-inch table. That helps. And for those of you with smaller printers, I've got files. I'm going to show you files where you can print this in sections. Okay, so my design goal on this was to print it with no supports, no brim, easy to clean up, and easy to assemble right off the printer without binding, without a lot of break-in. There is a little break-in going to be needed on here. If we spray a little lubricant on here, it'll make it better. But I just finished assembling this from parts right off the printer. It hasn't even been sprayed or with lubricant. It hasn't been broken in yet, so it's working pretty good. Versatile. Again, you can use your own camera. If you want an auto trigger, you can put cams on any of these shafts to trigger a switch to take a picture, or you can manually take the picture. You can put an encoder on here if you want. If you don't want the handles, you can use your own stepper motors or servo motors on here and turn these. So that was my goal. Now, the 3D scanner software I want to use is Zephyr Free by 3DF. Zephyr Free allows you to use up to 50 photographs. I chose to target 48 photographs instead of 50, because you can divide 48 evenly by 2 by 3 by 4. So you can take one elevation of 48 pictures, 2 elevations of 24 each, 3 elevations of 16 pictures each, and so on. So that's the reason I decided to settle on 48 pictures, and that's also why I designed this to be 2-speed. This is a 24-speed shaft here. This is a 6-speed shaft here. 24 to 1 and 6 to 1. The 3D files for all of this, they're all on Thingiverse. So you can use, I'll have the link in the description. You can use those. And again, there's smaller scale files out there, so you can print these on a 6-inch printer if you want to. I'm going to include some time-lapse videos as the printing, and then get into how to print these and the details of the files. These time-lapse videos I have to apologize a little bit for, because the crappy lighting involved. My setup uses LED lighting that uses rectified AC, so there's some strobing going on in the videos, but I think they're worth putting on there so you can see how they're set up on the bed and watch them being printed. Welcome back, folks. We're here to show you all the pieces, how to print them, and put them all together. So right now we have a table here full of parts and pieces. As you can see, all of these are fresh off the printer, and there were no supports and no brim, no raft, so essentially no cleaning, except my printer's putting out some strings like this. It looks like cotton candy. So each one of these shafts, I'm going to have to scrape a little bit to get those strings off of there. And these are tight fit, so you may have to do the same thing. But other than that, there's essentially no cleaning going on here. So let's see what we've got here. I printed all these in PLA. I printed a few prototype pieces with PETG, and PETG worked about the same, except for the shafts were a little bit tighter on that. So we'll talk about that in a little bit later. The printer I use is a Lulzbot Taz Pro, and I had it in the high detail mode. I believe that means a 0.15 millimeter layer height and 40% infill. You may be able to get by with a faster setting than that, but I haven't tried it. Okay, let's start with the turntable top. This is the turntable top here, the table itself. It's actually just a big ring gear. The file is called rack, like in rack and pinion. This is the pinion, and this is the rack, but technically it's a ring gear. So you print this flat side down like this, of course. You want to double check on your layering when you do your layers to make sure it's printed. It's setting flat on the bed. Now, one thing you need to watch out for on this part, the slicer I use is Cura for Lulzbot. And this part sometimes would confuse Cura. And in the center part here, it printed a couple of extra layers of unsupported bridging across there, which doesn't hurt it. It'll still work that way. It's just some extra cleaning you'll have to do in here to get that out of there. I found out by a little experimenting that if you pivot this on the Z-axis and then slice it, sometimes it will clear that up and get rid of it. So double check that and see if you can avoid those extra layers. Let's see next. Oh yeah, this part is about 10 inches apart across. That's a big part. If you don't have a printer that can do 10 inches, then I've included files that splits this up into roughly into thirds and roughly into fourths, and so that you could print it on as small as a 6-inch bed. And again, those files are included on Thingiverse. So one of the thirds has got the shaft on it, the other 2/3 and fourths or whatever do not. So you print one of them with the shaft and then several of the others, and then just glue them together however you see fit. Okay, now let's look at the base. The base is a large part as well. In order to make it where you can print this on a smaller printer, if you wish, I split it into thirds, and those files are included as well. I haven't tried those files, but they're included. You also print this flat side down like this, of course. Double check to make sure it's printed. And this will fit on a Lulzbot Taz Pro bed, but that's a big bed. That's like 11-inch bed. So if you have a smaller printer, use the other files. Okay. Now, talk about this base a little bit. Each one of these sections here is essentially a gearbox. And here's a prototype of one of those gearboxes, like right here. And it shows you what happens. It's got these pinion gears I showed you here fit in here. And the pinion gear and the tabletop by itself give you a 6-to-1. And you can put a handle on that shaft if you want and make it 6-to-1. Or you can also install this little spur gear over here with its own shaft, and that adds a 4-to-1 here, so a total of 24-to-1. So you have the choices, either a 6-to-1 or a 24-to-1. Each one of these shafts, you can also put your own cam or sensor or motor or whatever you want on those to make it do just about whatever you want. This prototype was made with PETG, and it works really nice. I like it. So let's see what else we have here. Okay, that was the base. Now, talked about this. This is the pinion gear. The file is called pinion, and it's got a spur gear on the back. Now, the gears, these spur gears have to be high precision. So what I did on these spur gears is, it's well known that on a 3D printer, sometimes the very first layer spreads out a little bit. It's what some people call elephant's foot. And in order to prevent that and give you a better fit, I either put an offset or a bevel on each one of these high precision parts so that it'll help compensate for that. It's still got a little bit of that going on, but not nearly as much. So you print 3 of these setting like this, and again, verify that it's flat on the bed, and you'll need 3 of those. So let's see. Now let's look at the shafts. There's 2 different sizes of shafts. Okay, long shaft, short shaft. The long shaft goes with this pinion gear. Both shafts have a flat section on the narrow end. If you look at it, it's got a D cross section. That D section stops before the other end, and that's where the gears, these gears, stop up against that, and that's puts it in position. So you want to make sure these are really clean when you get them off the bed. So if you have any strings like I have on here, make sure you scrape them down really good with your fingers or sandpaper or something and get that cleaned off. Otherwise it may jam up on you. I have printed these. The holes in here are 8mm, but since PLA is not 100% accurate, I printed these shafts slightly smaller. These are 0.4 millimeters smaller in diameter than that hole on the drawing. That makes it where you can put it together. Now, this is set for PLA. I did a lot of tests to see which size would fit. The testing for PETG, like on here, didn't need 0.4, they needed 0.3. So if you find that your shafts are coming out too tight and you can't put them in, you can either sand them down a little bit, or just simply when you print them, scale them down just a little bit. Again, this is 0.4 millimeters smaller diameter than the hole. If they fit too loose, you either print them a bigger scale, or once you get everything put together, put a drop of super glue on there. Makes it kind of permanent, but it'll get the job done. So let's do this. Again, these are the long shafts, and I've scraped this one pretty clean. So let's see if we can put this together. A little bit of force. Okay, that one's going to go. It's pretty tight, but we're going to get it on here. There we go. That went in there. So that was a little tight, but I got it on there. You may want to sand yours down just a little bit, but that put that in there. So right up against the stop like I showed you, right in there. Anyway, so next thing you need to do is take one of these rings. The file name for this is ring. Now when you print these, you print them flat side down, of course, and you'll need anywhere from 3 to 6 of these, depending on how many of these shafts you put on there. So let's put this on here, and right now we just put it on part way, like this, and then we put it in the base. And here on the long side of the base is where it goes. So you set this in here, then you go ahead and slide this up to where it's just almost touching. You don't want it tight because that puts a bind on things. And there you go, you see how easy that turns. Now to hold this in place so it doesn't come out of here, you're going to need this little device. We call this clip, and you print these with this big flat side down like so, no supports, and these clips go on here to hold the shaft in place once you get it set in there. And you just wiggle them and they snap on there. That one's done. And then you put one over here, wiggle it a little bit, get it to go on there, and there, that one's on there, and that holds it in place. And see how nicely that turns. Real simple. All right, now it's time for the other one, the small spur gear. And again, I put offsets on here to help it on that first layer being a little fatter. To help more even yet, you can tell which side was the side on the print bed. Well, identify that side. It prints flat like that, as usual. You'll need up to 3 of those for this. Now you get you one of the short shafts right here. Scrape it down real good. You may have to, again, you may have to sand off the extra debris if you have strings like mine. And then with the bed side towards the fat end, you put this on the D shaft as well up until it gets against the stop. All right, that one went a lot easier than this big gear. But if you find that gets to sliding around too much, again, you can just put a little drop of super glue. Again, another one of these rings, and it doesn't have a D, so it just goes on whichever way. That's a tight fit. Let's try this one. Okay, we got that started, and then it goes on here, and you mesh the little gear with the little spur gear. You mesh it with the big spur gear, and then you slide this ring up to where it needs to set. I need to clean that shaft off just a little more. Okay, let's put it on here and slide this up. Again, you don't want it tight. You just want it to hold it in place. And there you go. That's that spur gear. The small spur gear. We call that small gear. And just like the other one, you take these clips and put on here. And that one's in place. And now that one's in place. And see how nicely that turns. Right off the deal. Hardly anything to do. It's already turns pretty nicely, and as you use a little bit, it will break in, but it works extremely good by itself right now. I really like that. That's 24-to-1. Okay, so now we're going to also add a handle here. Again, this handle puts on here on this shaft, makes it 24-to-1. Okay, now if you leave this shaft out, the small gear, you could put this on here and make it 6-to-1. Okay, so what we're going to do on this one is install it here. It's got a D hole in it. By the way, these print this way on the bed as well. And again, no supports. It works really nice. And then these just slide on here. And again, instead of the handle, you could put a stepper motor on there, or a servo motor. You could put a cam on here to click a switch to take a picture every round. So, but me, for now, I'm just going to do it manually. I'm going to turn it once, take a picture, turn it again, take a picture, turn it again. That gives me 24 pictures per turn. Or if I wanted 48 pictures per turn, I go there, take a picture, there, take a picture, there, take a picture. You get the idea. So anyway, and see how nice that works? Right off the printer. Okay, that's one of them done. Let's do the other 3. Okay, there we go. As you could probably tell from the video, some of those shafts are a little tight, so feel free to run a little bit of sandpaper over those to clean off all the knobbies and stuff like that and make it a little easier. So there is a little bit of cleanup involved, but not very much. You don't have to clean supports out of the gears or brims off the edges or whatever. But you can see these all move real easy already, and once they break in a little better, get all the stuff out of there, it'll be done. Now, the fun part, the easy part. We're going to install this table. Now this table, this is just a centering pin. It doesn't support any weight. It just goes in this cylinder here and helps support it. I mean, helps align it on the center. These spur gears can hold all the weight. And they're pretty sturdy, so you should be able to put a fairly decent weight on here, a couple of pounds or whatever. So let's put this pin in this cylinder and then wiggle it till it sets down on those gears, and look at that, it works. Whoops, it jumped a little bit. So some of these are still a little stiff, but there we go. There we go, it's working pretty good. And after a little break-in, it'll work even better. For being right off the printer, working that good, it's pretty amazing. And you can see I can turn this and turn all the gears. What I've seen some people do is also spray this with silicone lubricant, and these parts ought to just really take off when you do that. So there you go. Works pretty nice. So there we go. And again, spray a little silicone lubricant on there, and after it turns a while, probably shouldn't need to be much break-in involved. Got a cross here in the middle, and there we go.